Hello, this is Rocky, and this is my video demonstration for Design Assignment 2C, in which we have 3 parts of Task 1 and 3 parts for Task 2. Right now I have my Solution Explorer open for Task 1, in which focusing on the coding regarding the overflow on normal mode. No overflow function for the C coding. I'm going to go ahead and open up that project. So looking at the coding, we could see that I've set definitions for an LED as well as a period and a duty cycle, and then I have unsigned cars to iterate loops for the timer, since the period and the duty cycle happen to be larger than what the timer 0 can hold. And then we could see that I have our loops demonstrated and a while loop and no overflow function, so it's just this coding. So if I go ahead and hit play, we'll see the code run smoothly without any errors. And then if we look at the device, that it is blinking. It is high for 0.435 milliseconds or 435 milliseconds, and low for the rest of the period, which the period happens to be 725 milliseconds. So no interrupts within this coding. If I open up the interrupt in normal mode, I'm going to go ahead and change the startup project. Oh, I need to quit debug mode. So the only difference is that we're using an interrupt to recycle the overflow. So we can see that the I increments to count the iteration of the timer using an interrupt, which is the regular normal overflow interrupt vector. So if I go ahead and hit play, we see that the code runs smoothly for the overflow version, interrupt overflow version, and then that the hardware reacts the same, in which it's high 60% duty cycle and low 40%, or for the rest. And switching to CTC mode coding, I'm going to go ahead and change the startup project. We need to quit debug. And then the only difference is that we're using a CTC mode, in which we set I set my OCR 0A to just the max of what the original timer is, so I don't have to change much coding, and I could leave most of the coding the same. But we could see that we use a different function for the interrupt regarding the compare A vector. So same functionality, just in CTC mode. If I run the code, we see that it runs smoothly, everything works the same, and we're at the same operation. 60% duty cycle high, 40% low, 725 millisecond period. So that concludes the coding for Task 1 for Design Assignment 2C. I'm going to go ahead and do Task 2 now, which, let me go exit this. If I go to Project, open Design Assignment 2C, Task 2. I'm going to go ahead and open that file. And then it'll take some time to load. Give it some time, in which this coding will show that if I hit the switch, it will be high for 1.25 milliseconds. Going to Design Assignment 2C, Task 2, regular normal overflow without any functions. I'm going to go ahead and set that up as the startup project, we can see that the coding, we use the unsigned cars, and we have similar setup where we set the timer 0, and we have a similar fashion coding from design assignment task 1, and no overflow function. So I'm going to go ahead and run that code. Everything runs smoothly. Now we could see that the LED is constantly lit up, which that's what it is when it's low. When I click the switch, it'll turn off, which means it goes high for 1.25 milliseconds or seconds. If I click it, we see it's high, and then it goes back to low, which is the LED on. If I do it again, it does the same functionality. So we could see that it works as it should for task 2. Same functionality, except using timers, or a timer 0. Now going to the overflow function of the same exact task, I'm going to go ahead and set up the startup project. I need to quit debug mode. And then I have that code set up. We could see that there isn't much difference with the coding, except we use a timer interrupt vector for its overflow to count the iterations of the counter, of the timer. If I go ahead and play the code, it runs smoothly again. And then we see we're at the same functionality. I click this switch, and then it's high, and then back to low. So we could see that works just fine. This is the overflow version of the same task. So opening the CTC version of it, I'm going to go set that up as a startup project. Oh, I need to quit debug mode again. And then if I run that code, we could see that the coding looks similarly to the previous one, except we use the CTC mode and then set the compare match output mode. And we have the compare function vector, which does the same functionality, not much difference, except we're in CTC mode. So if we run this code, it should run the same as the previous task 2 for normal mode, and we see that everything looks the same, and it's high and then back to low. Everything works the same except using interrupts for CTC mode. And this concludes my demonstration for Design Assignment 2C. Thank you so much.